Hi everyone, welcome to today's session. It's called Why Do You Need Data Protection for K8s or Containerized Applications within Kubernetes. This session is not a product pitch. This is not going to be about how our solution is better than others or however you want to phrase it. What we're going to talk about today is really focus on, as a user, whether you're in the DevOps organization or whether you are an IT manager, a VP of IT, or a director of IT who's been asked to look after and understand containerized applications within their organization. So what we're going to do is going to look at best practices and move from there into a thought leadership presentation around this. Before we move on, I'd like to introduce myself and my co-presenter. My name is Andy Fernandez. I'm a Senior Product Marketing Manager here at Zerto. I am joined by Egon Van Dongen. He is a Solutions Architect as well, and he is here to help us really understand exactly what we should be looking for in a Kubernetes solution or a Kubernetes data protection solution. So let's take a look at the agenda, and from there, let's get started. So first, we're going to look first at the adoption, the evolution of persistency within Kubernetes, how it all started, how things have evolved, and why we live in a world today where we understand that persistent data needs protection. We're going to take a look at several scenarios in which shows you what happens when my environment goes down, what happens when I lose that data, what happens when I can't get back an operational after running this. And then after we have an understanding of the scenarios and you can understand whether your organization requires this or not, we'll take a look at what are the key characteristics or the key design elements that your organization needs to look for when you're looking at backup, disaster recovery, data protection for your containerized applications. So with that, let's get started and take a look at persistent data in Kubernetes. So with that in mind, in order to really understand the evolution of persistency adoption, we have to understand that persistent data within Kubernetes, and especially where the storage comes from. So let's talk about storage within persistent data in Kubernetes. Well, Docker takes a simple approach of mapping a node path to a container path so that a container can write to a portion of that volume. Kubernetes, however, takes a much more eloquent approach in that we have a concept of these persistent volumes as well as a persistent volume claims that exist. A claim is very similar to something like a code check claim, and that as long as you have the right ID, you can access the volume. So what Kubernetes will do is it will actually map whatever storage is available underneath to the various pods that have requested storage. And it does this via CSI or pods that have, or Kubernetes storage drivers that are available from the various providers. This could be from physical, virtual, or from your favorite cloud provider as well. So what the developer has to do now, or you as a developer, is deploying its containerized workloads basically to specify the class of storage that's needed, the size of the storage that's needed, as well as that claim. Once that workload is deployed, the underlying storage resources are created and allocated to that claim. What this allows you to do is actually have the storage be completely separate from the container. So the container could have a very short lifetime. It can come up and go down in multiple times. It could even fail. But then the storage will persist. And every single time the claim is used, that storage can be accessed. So now that we have an understanding or description of persistent data in Kubernetes, let's take a look at its evolution and its adoption. Now, I love this visual, but let's talk a little bit about the adoption of persistent storage in Kubernetes. We really have 4 stages of evolution here, from the pure stateless Kubernetes deployments all the way to Kubernetes persistent volumes or PVs. And in between, we've got persistency living in other places, such as in VMs or in databases as a service. So we're going to dig just a little bit deeper into each one of these. So at a very basic level, you can have a complete stateless Kubernetes application. This is where a lot of it started. The source code, which is the crown jewel in this case, is stored in an external system. This could either be a SaaS or it could be hosted on a VM. Coupled with a CI/CD pipeline tool, right? Think Jenkins, JFrog. This system is going to take the code, run it through a pipeline chain, make sure that these images are created, and then pass along to Kubernetes. So then Kubernetes can deploy the application. At any source code, or anytime source code changes are made, the entire process is essentially repeated. The containers in this case don't really rely on persistent data underneath. The source code and pipeline systems can either be provided as a SaaS or they could be running as part of your virtualized infrastructure, which would already be protected by whatever solution you have from a VM perspective. Now, What about persistency in VMs or now what about database as a service for persistency? This is the next chain in this evolution, and it's getting rid of those virtual machines that essentially provide that persistence layer. So a good observation that we've made is that our own customers moving to database as a service, or PaaS services as they're commonly known. In this case, database is provided as a service. You're not responsible for the OS or even standing up the infrastructure. You're merely a user of that shared database environment, a tenant, if you will, on that database environment. In your containers, once it instantiates, it can connect to the database. It can read, write the persistent data to and from those PaaS services. However, pros and cons, it does take a lot of management effort off. On the flip side, you're dependent on that vendor for both service levels as well as architectural limitations. So if you want to scale one part of that database to serve your container, it needs more. You're pretty much bundled in with a general purpose type environment and you don't have the flexibility. Now, as far as resilience comes in, you're relying on that resilience to the database vendor provides, right? You can't dictate the resilience, you're relying on somebody else. You may be able to extract that data from the database to retain it, but the question comes where you're storing that persistent data. So it's really not a complete solution. There are a lot of limitations, a lot of design limitations as well. Now, we've taken a look at persistency in VMs, stateless applications, database as a service for persistency, but now let's take a look at Kubernetes persistent volumes. What we see as the final step in this evolution is truly getting that entire application to follow a microservices architecture. That includes the persistent data. So not only do you have the components that do not require state running as containers, but also the stateful ones with use of persistent volumes running as containers. That allows you to do two things. One, it obviously gives you freedom of choice so that the containerized workload can be deployed anywhere. On-premise in one cloud service provider, another cloud provider, back to on-prem, physical, with a hypervisor, without a hypervisor. You can make it mobile, but also including the database components as part of your CI/CD application pipeline. So just as you would test and deploy application and front-end changes, you can also deploy the database changes in that manner. So if you've truly achieved the separation of a DevOps and an IT role, this is the ideal state that we're looking at. Now we're all getting pretty excited about persistent workloads, but before we get excited, we have to start thinking about the protection of that data itself. We see the value in its deployment, but how about the protection? So from an evolutionary standpoint, having that persistent data be part of the container provides or gives you the most flexibility and scale, as opposed to being locked into a specific path or SaaS service, or even locking the data on VMs. We have to now think about the resilience. And by resilience, we have to think about the ability to be able to back that data up, to restore it, the ability to replicate it from a disaster recovery standpoint, be able to fail that back, as well as provide migration services. And as more containerized workloads move from test dev into lower tier production and even into higher tier critical production apps, these aspects become much more important because it's your data. It has to follow the same governance rules that existed for virtualized data and even for physical data. As much as we want to get away from the constraints of the physical and VM world, that data still requires the same the same protection. Now, I've mentioned a lot of terms around data protection, being able to back it up, being able to recover that data, but really it's about making sure that you're able to protect your organization, protect your applications, and reduce any type of data loss and any type of downtime. And what we've already talked about is how phenomenal Kubernetes is for automating deployments, for scale, for load balancing, for workload monitoring, for managing the storage via the CSI drivers as persistent volumes, and the claim mechanism, as well as ensuring that services networked between pods and across pods are provided. However, what Kubernetes does not do a good job of today is ensuring that you have a native method or something purpose-built in order to back up that persistent data. Also, in order to back up the configurations of those deployed applications, not just the data itself. Extending that to not being able to provide disaster recovery across clusters as well. It's not just being able to eventually restore that data. It's also resilience around DR, being able to get back up and running. And mobility as well, whether it can be from one time or for expansion or for bursting capabilities across clusters or even across platforms, say from on-premise to public cloud or even across public cloud providers. So there are some gaps that we as an organization have been working on. Just have we been existing in the virtual infrastructure world as well. Now, what we're not here to do is talk about what Zerto delivers, with data protection as code. No, what we want to talk about now is understanding what are the threats out there right now to your environment, to your Kubernetes environment, and what to really look at a checklist of what's important. What are the data protection challenges that you face without any solutions? What are the data protection challenges that you face with your existing solution, maybe that isn't purpose built? But what are the threats that we're facing? Well, we know that there are traditional threats to downtime and data loss, whether it's corruption, outages, you name it. But a threat that we're really seeing is the growth of ransomware. We know about ransomware from a VM perspective. We know it's a high growing volume of attacks. Prices are increasing, and so are the consequences. But as more organizations are adopting containerized applications, hackers are modifying their behavior and their attacks to also do so. So we had an assumption maybe a year or two ago that this was a VM issue. This was not a container issue, but it is a container issue, and it's here. And we have to be able to make sure that as organizations, we're able to protect our applications from it. So with that in mind, we're going to talk about resilience, being able to recover, restore data at any point in time, and minimizing data loss. So with that, I'm going to transition over to Egon, and Egon is going to drive through exactly what to look for in a data protection solution.
Thank you, Andy, for the introduction. As Andy already mentioned, my name is Egon van Dongen. I am a principal architect at Zerto, and I've been with the company for almost 6 years. So let me take you a bit deeper into the world of Kubernetes and what ideally is needed to create a protection strategy in the containerized world. As the previous slide already illustrated, the native capabilities in Kubernetes for data protection is not sufficient. There are already multiple solutions that claim to deliver data protection for Kubernetes. But as there are many scenarios in which your application and data in Kubernetes can be compromised, it is wise to at least know what capabilities the solution must have. So, what should you look for in a solution when creating a protection strategy for your containerized environment? Let's quickly have a look at what is natively possible, and moreover, what am I missing in the existing solutions right now. First of all, yes, Kubernetes does have an HA mechanism natively. But the options in the solution for disaster recovery are actually very limited, and on top of that, there is no data protection option at all possible. With many of the solutions at hand today, most of them are not purposely built for Kubernetes. They are refactored tools that are using legacy technology such as snapshots to secure data. When using innovative solutions like containers, it does not make sense to use legacy solutions to secure them, not to mention the impact that those legacy techniques will have. Furthermore, it is the same as in the virtualized world, not enough just to secure the data. Persistent data must be protected, but if you want to recover an application, all related resources, such as configs and services, also must be protected. Not to mention if an application consists of more than one container. So an application-centric approach in protection is an absolute must. Persistent storage in a container is becoming more and more commodity nowadays. People are still not convinced that the persistent data in these containers need to be backed up. But the persistence is constantly evolving inside these containers. You need to be able to track these evolvements, not only from a dev point of view, but also from a compliancy point of view. With all that persistent storage, there also comes a pitfall. Locking the data in to, for instance, VMs, or platform as a service solutions, and software as a service solutions. Once in, it's hard to move somewhere else with your data. So by backing up or replicating your persistent data anywhere, you are freeing your data to be used on any platform. Together with the persistent storage also comes stateful and stateless components. As they are a part of the application, they should be able to be recovered together with that persistent storage as one whole. A key capability to achieve the best strategy possible is, of course, continuous protection. A continuous data protection technique is required for persistent volumes. With this CDP, you can enable the lowest RPOs possible with checkpoints on a very granular level. Checkpoints created should also be able to get tagged, so management and search options get much easier. By leveraging those checkpoints, one could also create an ordered way of recovering applications, as they are able to get organized in a smart way. The DR solution should also be aware of the environment it's protecting. A historic agnostic volume approach is very helpful in this, not only for the awareness on what the platform the application is running on, but also it should be able to assure you that the persistent volume is consistent at the destination it's being sent to. As mentioned before, the solution must be able to protect an entire Kubernetes application. This can be achieved by using virtual protection groups where all the resources are defined that make up the entire application. For a data protection solution to be integrated as best as possible in a Kubernetes environment, the solution needs to at least have the following capabilities. 1. Have the option to do data protection as code. For instance, defining your protection strategy in YAML files, the same way as you are used to manage your Kubernetes environment. 2. The solution should be able to extend the kubectl commands with specific commands purposely made for the protection of these containers. So a Kubernetes API extension has much value in this. And 3. Creating and maintaining declarative configurations the best and most adaptive way possible in configuring and creating your recovery strategy. All in all, it's very important that the solution you choose that protects your applications and data in Kubernetes should be a solution that is actually made especially for Kubernetes. It has to be native to the environment it's securing. The solution has to be designed and deployed and used as a normal Kubernetes application. This Kubernetes native solution should be platform independent, whether you are running your apps on an OpenStack on-prem or in AKS in the cloud, it should not matter. The solution you choose should be able to make sure on all platforms to secure your apps. Beneficial to this, the solution should also be able to secure your app from one platform to another. And finally, as Kubernetes is made to scale with your needs, so should the DR solution be. Scaling with the needs of your environment is almost obvious. Summarizing, there are a lot of factors and capabilities involved in choosing the right solution for your data protection strategy. I hope I have shed some light on what it takes to make the right choice. Not protecting your applications or not doing it natively to Kubernetes can create more difficulties than you can imagine. With this food for thought, I am handing it back to you, Andy.
Thank you, Egon. Now that you've kind of seen how we're interpreting the evolution of stateful data within Kubernetes and what are the threats that you're facing from a downtime, from a data loss perspective, the health of your application, and looked at how do you qualify a solution today with all the marketing that's out there? What do you look at the design elements of a true native backup disaster recovery experience. So with that in mind, as I promised, this is not a product pitch. I do ask you that you check out what Zerto can do, what Zerto's data protection as code, our Zerto for Kubernetes experience can do. And the one thing that I ask is, instead of just reading marketing documents, just take a look at our labs. Be able to see exactly how Zerto works. Test drive it for yourself in a self-paced environment whenever you want. You see that link there. You're able to simply access, register for the labs, and start using it. If you want to learn more, check out our website. There's a lot of key information, both on thought leadership, sponsored information that we've paid analysts to deliver on how should you protect, what are the configuration elements, what does this look like today, what is it going to look like in a couple of years. And also, as you might want a live tailored demo, please get in touch with our sales organization. We'll bring you into an expert, simply explain exactly how it works, and we'd love to see you there. So with that, thank you for your time, and I hope you have a great day.